Okay, I hope you've had a chance to actually have a look at basically how we might calculate V1. All right, so we'll do it together. So let me draw a little equivalent circuit to help us with this. So I'm going to show you V in. So here is V in, referenced like so. There it is. Okay, connected to ground. There's my R1 resistor. All right. Now, this point here, this node here, I'm going to call V1. Now remember that V1 is actually connected into the non-inverting input of the operational amplifier itself, but basically there's no current going into the op amp, so as far as this calculation is concerned, I don't really need to consider that connection. So then here is my R2 resistor, and I'm just going to model V out, referencing it like so, and there is my V out. Okay? So I'm going to use superposition now to actually calculate that V1 voltage. All right, superposition. Let's look at this V in acting on its own, which means what? I zeroed the V out. Okay, so really this R2, this side of R2 is connected to ground, isn't it? So let me draw a little equivalent circuit of that. So I've got my V in acting alone. Okay, there it is, that's ground. Here's my R1 resistor, and R2 now is really connected to ground, and the voltage I'm interested in is across that resistor, which is what? It's a component of V1, and so I'm going to say that's really my V1 prime. So therefore, V1 prime is across that resistor, so that is equal to what? R2 over R1 plus R2 times V in. It is a voltage divider, is it not? Okay. Now let's consider V out acting on its own. What does that mean? It means we zero this voltage source over here. In other words, now the R1 is connected to ground. So let's draw a little equivalent circuit of that. So here is my V out, and this is my R2 resistor now. So there's R2. And the R1 resistor is actually connected to ground like so. We're looking at this voltage across R1, which we're saying is what? V1 double prime. It's the other component. So V1 double prime, voltage division, is simply what? R1 over R1 plus R2 times V out. All right, so here are the two components now of what? Of V1. So therefore, V1 is equal to what? It's equal to V1 prime plus V1 double prime, which is equal to what? R2 over R1 plus R2 times V in plus R1 over R1 plus R2 times V out. All right. Once again, I'm showing you the operational amplifier circuit. We have our expression now for V1, which is in terms of the V in and the V out. Let's start by assuming an initial condition whereby V out, let's say, is equal to a minus 15. What that means then is that really this V1 voltage here has to actually be less than the reference voltage Vref in order for that to be the case. Now we know that if we start to increase V in, we'll make V1 bigger, and we can increase this to such a value that V1 will be equal to the reference voltage plus a little bit. And that is when switching will occur, when basically the output goes from the minus 15 to the plus 15. So what we could say then is that switching occurs when V1 is actually equal to that reference voltage. Now in reality, we know V1 has to be just a fraction bigger than that reference voltage. Okay, so I could take this expression here and I could equate it, could I not, to the reference value. So at this switching point, I can say that what? V1 equals V reference, which is equal to R2 over R1 plus R2 times V in. Now remember, I put that initial condition in there. That is now what? A minus R1 over R1 plus R2 times 15. Okay? That's when switching is going to occur, when this V1 has become equal to that reference value by having increased V in to that amount to make that so. So I'm going to leave you with a question here, and I'm going to say, what is the value of V in then required to actually make that happen? So perhaps you could work that problem, and then next time we'll come back and do it together.